Hello everyone, welcome back to another lecture on the course Python Fundamentals, Building Blocks for Aspiring Developers. We will continue with the seventh module. We are at the 20th day of our agenda. We will look at polymorphism. So let's begin. So polymorphism is also a concept in object-oriented programming. So what it allows us is to have different implementations of the same method in different class. Okay, so let's say we define one method, but we want different outputs from those methods based on different classes, on inheritance. Okay, so let's say in one class we want the function to do something else, but in the other class we want the function to do something else, but in the parent class we still want to have the function in case one of our child classes does not have that function. Okay, so we use polymorphism. So what it does is that it provides us with flexibility and extensibility. So there are two main concepts, that is method overloading and method overriding. So let's first have a look at method overloading. So it is a feature that allows a class to have multiple methods of the same name, okay? But the parameters are different. Maybe one has two parameters, maybe one has three parameters, something like that, okay? And the method which is called is based on the amount of arguments that we give when calling the function. Now, unfortunately, Python does not support this. Python, because is meant to be more towards data science and um, data engineering sort of language. It is not meant to create complex softwares. This is why it does not have this sort of functionality. But other programming languages such as C++ and Java do have this functionality. But still, we can have a look at the example of how it looks like. So for example, we have a method called add and it takes in two arguments. We have another method called add, but this takes in three arguments. So once we create an object of the class and we call the method, it depends on the number of arguments we give that which method is being called. So if we give two arguments, this first one will be called. If we give three arguments, the second one would be called. So we will have a look at why is it useful. We will obviously not be able to run the code, but in the code we will write it and we will see where it can be useful. Okay. The second one we have is method overriding. So what method overriding is that we kind of overwrite the method in the child class. Okay, so there is some method that is already defined in the parent class, but in the child class we want to do something different using the same method. Why we want to use the same method? Because conceptually it is the same method. Let's take this example. So we have make sound, so an animal will make sound, okay, but we do not know what animal it is, so we just put in some generic animal sound, okay. But in the child class, we know that it is a dog, and we know that dogs make a barking sound. So we want to use the same method name, but do something different in the method body. That is, we want to print bark, but we want to keep the same name because all of the animals still make a sound. So we want to allow the user to use the same method name, so it is not too much information for the user, okay, and it is also easy for us to code, okay. So that was this. The concept is, I mean, it is pretty simple if we have a look at it, um, but we will start coding and have a look at that. So let's say we have a class, let's say shapes that we have in mathematics. So let's say we have, I'm not going to define the constructor. So let's say I have well, in fact I can define the constructor because I will be using it afterwards. So I say self, I say length, okay, and then I say self dot length is equals to L, okay. Now let's say we have a function called define calculate area. Now we say self, and in fact, let's just get rid of this one for now, so it is easier for you to understand the concept. So we have the length, and we say area is equals to length into length. Okay, so this one is, let's say, to calculate area of square, calculate area of a square, right? Now we also have the same one, but this one we have a rectangle. So the area of rectangle is length into width. Okay, so I'm going to change it here. So this is calculate area of a rectangle. Okay, now what would happen is that ideally in C++ or Java, the sort of languages which supported, we would say square is equals to shape. Let's say we created this one, we say rectangle is equals to shape. Okay, or now we want to calculate the area for square. We say square dot calc area. We would just give in one parameter, that is the length of one side. So what we'll do is that based on the parameters, based on the arguments that we give, it says okay, it only has one argument. It will go in the class. It will see okay, which method with this same name has only one argument, this one. So it will call this one. Okay, but instead of this one, if I do rectangle dot calculate area, I provide, let's say, two lengths, one length and one width, two values. So it will say okay, it has two arguments, so it should execute this function. Okay, so what this allows us to do is that in one class we can have different sort of implementations of the same method, and we can even call the same method afterwards, but the method called is different based on the number of arguments that we give. You see how it allows us to use the same method name for different objects but still do different computations based on the number of arguments. Okay, so you could also even have like something like define calc area, and let's say length, and maybe you say area is equals to pi r square. We say pi multiply by l multiply by l, something like that. And you have another one, let's say circle is equals to shape, and you want to, but for this one it will be confusing. So what we want to do is we want to, let's say, add another argument, let's say pi, and let's say l. So I want to say pi into l1 into l. So this is just for an example because this kind of looks messy, but still you should be able to understand the concept of this one. So we say okay, length 1 is 4, let's say pi is 3.414, and again length 2 is 4. So this will now have three arguments, so it will call this function. Okay, so you can see that in one shape we are able to calculate areas of different shapes using same method but different implementation each time. Okay, now let's go ahead and look at the second concept. So for that one, let's say we have for polymorphism, let's say we have an animal, we say define underscore head. So in the self, let's just define something. Let's say self dot color is equals to brown. I mean, just to keep it simple and not to initialize it. So let's say I say define make sound. So if it is a animal, I don't know what animal it is, I can say okay, general sound. Okay, But once I have, let's say, an animal dog, which I know makes what sort of sound, what I can do is that I can say define make sound. Okay, not this, I want to say and bark, right? So now if I have t is equals to oops, dog, and I say d dot make sound, what it will do is that it will make sound of the dog, because now both the methods have the same name, but since we have kind of overwritten it here, overriding, it will call this method. Okay, now let's say we define an animal is equals to animal, and we say okay, here dot make sound and print it. Now since it is for the parent class, it does not have any method overriding, it will use this method. Okay, now let's say we also have another animal, let's say cat, but we do not want to put in this method. Okay, we just want to say something else. I mean, I'm just writing this because if I don't write something in the body of the class, it will give a syntax error. So I will just say get color. Okay, and let's say return one. Okay, so just ignore this one. I'm just writing this to complete the body of the class, so it does not give me a syntax error. Now, if I say I have a cat, and if I ask the cat to make sound, it will say general sound, because this class cat does not have any of its own method make sound, so it will automatically go ahead and make use of the method of the parent class, this one make sound. But since our class dog has a method of the same name, it is kind of overwritten. So whenever I do make sound, it will make sound that is for this class. Okay, now this concept is again useful because maybe I'm doing a cat, but maybe I'm doing some other animal. I do not want to include the sound of that animal, but I just want to say, okay, just do general sound. For only some of the animals I want to have a sound. So for the subclasses that represent those animals, I will have this same method written again. So it is overwriting it. And for the other ones, I do not want to write the method again, so it will automatically use this one. Okay. So this is the purpose of method overriding. As you would have noticed that in this module, most of the coding done was not too difficult. It used the same sort of concepts like print statement or methods, which is kind of like functions, attributes, which is also kind of like variables. Um, the syntax was pretty much the same that we have been learning in the previous modules. It was just that these were some different concepts. So what I would say is that you need to understand these concepts much better. You need to focus more on understanding the concept. Okay. Once you understand the concepts, then you can code easily, but your main emphasis should be on understanding the concepts of object oriented programming that we learned. Once again, I would say that we do not expect you to become a master in object oriented programming after this module. It is just here to give you kind of a sneak peek into what object oriented programming looks like. And with practice, um, with writing code, you can get familiar and better in object oriented programming. And now this brings an end to the seventh module. And in the next one, we will start a new module.